this conversation.
It makes sense, though.
No, I'm sure it does.
Were you feeling a little bit like Joe when Elon was talking about his electric airplane? If so, no worries. I'm going to break it down and explain it for you. Here we go.
What do you got? What's going on?
Well, I mean, the exciting thing to do would be some sort of electric vertical takeoff and landing supersonic jet of some kind.
Vertical takeoff and landing, meaning no need for a runway. Just shoot up straight in
Yes.
the air and then. Ooh. How would you do that? I mean, they do that on some military aircrafts, correct?
Yes. The trick is that you have to transition to level flight, and then the thing that you would use for vertical takeoff and landing is not suitable for high-speed flight.
So you have two different systems.
I've
Vertical
thought about
takeoff
this
and
quite a
landing
lot.
system.
I've thought about this
Okay.
quite a lot. The interesting thing about an electric plane is that you want to go as high as possible, but you need a certain energy density in the battery pack because you have to overcome gravitational potential energy. Once you've overcome gravitational potential energy and you're at a high altitude, the energy you use in cruise is very low, and then you can recapture a large part of the gravitational potential energy on the way down. So you really don't need any kind of reserve fuel, if you will, because you have the energy of height, gravitational potential energy. This is a lot of energy. So,
All right. So to understand what Elon's talking about here, let's just start with the basics. Like, what is gravitational potential energy? So what gravitational potential energy is it's a form of stored energy that can be converted to another form of energy by the force of gravity. You can think of it kind of like a battery, but instead of being a battery cell, you're just using the force of gravity to store the energy. So to demonstrate this, let's look at the situation here where we have this organic fair trade donkey, which is going to lift this mass up a certain height. Now, as the donkey moves forward, the donkey's energy is actually being converted into gravitational potential energy stored in the mass that's being raised. Now, let's say we want to use that energy captured in that mass and convert it into something like electricity so we can power a light bulb. Now, let's say that we have a spool of rope that's, the rope's wound round and round and round this spool, and that spool is then connected to a generator by a belt. Now, let's attach the rope from the spool to where the donkey's hooked up, and then now we can let the donkey free to go back and feed on the farm. Now, you can kind of imagine what's going to happen here. Gravity is going to pull that mass down and spin the spool, which is then going to turn the generator, which is going to generate electricity. Now, if we make the assumption that things like friction and generator efficiency are relatively negligible, the really cool thing about this system is that all the energy the donkey put into raising that mass gets converted into electricity on the way out. So how is this relevant to an electric airplane? Well, just like our donkey example, once that airplane is up at a high altitude, a portion of that energy can be recaptured on the way back down. You can think of it kind of like regenerative braking in an electric car.
So you really don't need any kind of reserve fuel, if you will, because you have the energy of height, gravitational potential energy. This is a lot of energy. So once you can get high, the way to think about a plane is it's a force balance. So the force balance. So a plane that is not accelerating is a neutral force balance. You have the force of gravity, you have the lift force of the wings, then you've got the force of the whatever thrusting device, so the propeller or turbine or whatever it is, and you've got the resistance force of the air.
An important thing to understand about this force balance is that the lift force required to maintain the plane's altitude is equal to the weight of the plane. I'll say that again. The lift force required to maintain the plane's altitude is equal to the weight of the plane. Now, the weight of the plane doesn't change with the altitude that you're flying at. So that means that the amount of lift force required to maintain level flight is always equal to the weight of the plane. It doesn't change whether you're high or whether you're low.
Now, the higher you go, the lower the air resistance is. Air density drops exponentially, but drag increases with the square. An exponential beats a square. The higher you go, the faster you will go for the same amount of energy. And at a certain altitude, you can go supersonic with less energy per mile, quite a lot less energy per mile than an aircraft at 35,000 feet, because it's just a force balance.
So if you didn't catch all of that, the general concept here is that air density decreases with altitude. Now, if you have something really dense, like for example, molasses is more dense than water. It's harder to push something through molasses than it is through water. So it's the same thing with air. Air gets less dense at a higher altitude, therefore it's easier to push the plane through that air. Now let's bring this back to the ground for a second. Let's say that we have a crate and we want to pull this crate across an asphalt road. Now imagine yourself grabbing that rope and running as fast as you can. So you're going to pull that crate across the road. What's going to happen? You're going to be able to accelerate that crate to a certain speed, and then it won't be able to go any faster because you don't have any more force. You can only generate so much force. In this case, the asphalt road represents high resistance, or flying at a low altitude in high density air. Now, if you were to change this to an ice road, like something you have up in northern Canada, you'd now have a very low resistance surface, which would be representative of an airplane flying at a really, really high altitude. So if you do the same thing and you grab that rope and you run as fast as you can, you're going to be able to move that crate a lot faster. So you're going to move a lot faster, but you're not actually generating any more force. The maximum force you can generate is the same regardless of the surface. The same is true for an airplane flying at high altitude. If you can generate the same amount of thrust force, you can go faster. You can go faster for the same amount of thrust force. To recap, getting up high, up to a high altitude, doesn't actually cost you a whole lot of energy in the long run. It does take a lot of energy to get up to a high altitude, but since you can recover a large portion of that on the way down, in the end, it doesn't actually cost you a whole lot. When we look at the force balance, maintaining a plane's altitude requires the same amount of force regardless of how high or low it is. So it doesn't actually matter if we're high or low. We still need the same amount of force to keep the plane at a constant altitude. Lastly, the higher we get, the lower resistance we get in the air. So that means there's less drag, which means we can go faster. We can go faster for the same amount of thrust force. Now, there's all kinds of technical challenges with this, but the really cool thing about Elon Musk is he takes something really complicated like an airplane and he just breaks it down to its very core components, and you just look at the first principles of what's going on and you think, how can I change this and how can we use this to our advantage? At least in my opinion, I think a lot of scientists and engineers have a hard time doing this, but as Elon Musk has proved again and again and again, this is really where true innovation lies. Now, if you're going to take one thing away from this video, is that there's huge advantages to getting really high. And if you can do it right, getting really high doesn't actually cost you much in the long run. And while you're really high, there is much less resistance. Thanks so much for watching. Please subscribe to the channel. I really hope you learned something, and stay good.